Right. Yeah. So we're live now. So today we have Pete Goddard, the CEO of Deephaven, and Chip Kent, who is the Chief Data Scientist at Deephaven. And today they're going to be discussing Deephaven, which is a real-time query engine for streaming tables. And this was spun out of a quantitative hedge fund called Wale Capital. And we'll get into that story in a moment. So yeah, let's start off with a little bit of an introduction. So hi, Pete, and hi, Chip. Go ahead and say hi and give a little short introduction to yourself. And if you're in the chat, go ahead and say hi and where you're from. Make sure you can hear us, and we'll get this started. So how's it going?
Hi, how you doing? So thanks so much for the opportunity to speak with you and get to know some of the community out here. I'm Pete. I'm the CEO of Deephaven. I was an engineer in school out of the University of Illinois and immediately went into the capital markets, first in Chicago, then London, then back in the Midwest, and have been involved in more or less quantitative finance for a couple of decades until I became a little more fascinated with the computer side of things rather than the money side of things, and became all about software in the last 4 or 5 years.
Awesome. Hey, Chip.
All right. Yeah, thanks for having us. Chip Kent. My background is in scientific computing, particularly quantum mechanics and related things. After that, I spent a while at Los Alamos working in the high performance computing environments group, and then joined Pete to start Walleye quite a while ago. And as part of that work, I became very interested in, how do we make quantitative researchers productive and do that while dealing with real-time data? And, that led to Deephaven.
Awesome. So yeah, so as I understand it, Deephaven is this real-time streaming solution, and it kind of includes a lot of many things under one umbrella. But I guess before we talk about Deephaven, let's talk about its origin. So going back, you mentioned y'all started Walleye Capital, and I believe that was in like 2004, 2005, and I'm sure you've seen a lot in that period. That's what, over 15 years, and goes through many different market cycles. So and also the technology that was available to this channel is primarily like the person at home using off-the-shelf APIs and open source tools. But yeah, how do you go about starting something like Walleye Capital? Let's talk about the origin story and what the technology landscape looked like, how you got access to data. How do you start something like this up?
Sure. So from about 2000 to 2004, I was involved in managing trading businesses at fairly established organizations. So, and those trading businesses, A, were always in derivatives, and B, were always or were either involved in or were moving heavily in the direction of automation. So, I had some experience in managing teams that were thinking about markets and thinking about the technology to find alpha in markets, so to speak. And in 2004, I was approached by a mentor, arguably, to see if I'd like to start a new company rather than continue to work for Citibank at the time, or Citigroup at the time, I guess. It was a flattering conversation. Together, we thought of what it would take to start the company, mostly from a leadership perspective, what sort of personnel, what sort of partners we would need. And we identified a few partners that, quants and technologists and people that were good at a few different asset classes and stuff like that. And we brought them around the table and started Walleye. So it's a daunting task, as you can imagine, because it's a very competitive environment, and listed securities have a whole stack of challenges to them. And from our point of view, listed derivatives, that stack is, both higher and quite a bit broader. So it was scary but exciting, as you can imagine. And we were fortunate to be able to attract quite a bit of talent early on to the project. And Chip's one of the people that joined very early. For building systems and developing strategies.
Yeah, and just to add a little more to that, you were asking about the technology at the time. What was available was very minimal. Almost everything we created, we had to create from scratch, just because there was neither an open nor a proprietary solution we could use.
Excellent, excellent. Okay, and then so you mentioned that it was highly competitive. Can you talk a little bit more of that highly competitive nature? I know I listened to a few podcasts with you, and you kind of called it an arms race. Can you talk about some of the things you had to do to compete in this type of environment?
Sure. So our initial strategies were all focused on option market making, which really means, and probably this is a little bit different from the natural footing of most of your audience, in that for the most part, as a market maker, you're certainly trying to have theoretical values with predictive alpha, but you're very much trying to make money by creating edge at the time of trade. So rather than only making money by holding on to positions, oftentimes you're trying to hold on to a fraction of the bid ask after your trade. So if you say, oh, you think something's worth 10, the market is 9.11, you sell it at 11, your goal is to hold on to some fraction of that 1 unit of expected value, so to speak. There at the time, maybe in 2000, the markets really went electronic there in the late 90s in the options market. It was really around 2000 with the International Securities Exchange that came in. There was quite a migration of players to these types of strategies. And as you can imagine, the best business in all of Wall Street is being the fastest, always, because to a certain extent, if you can be the fastest, you can predict the future very well, because you're predicting the present better than anyone else, so to speak. So there's tremendous investment in trying to be fast to very much sway the complexion of trades that you're interacting with as a market maker, so that there's that you're not too biased, that you're not trading a worse mix of order flow than your competitors. So you want fast systems, you want systems with good quantitative alpha in them, and you want to have extreme breadth of coverage as well, so that you can diversify your risks across thousands of stocks and hundreds of thousands of options.
And so is this a need for speed partially what motivated you to develop Deephaven and your own technology solutions over time? Can you talk about how
Sure.
you eventually developed your own systems there?
I would say yes, but in a very indirect version of that, that maybe you wouldn't expect to that question. So we were exclusively in these types of businesses for 7 years. So again, think primarily edge retention, edge capture businesses, what we call them, market making businesses, where really you're as much just trying to trade what's out there and hold on to that edge, rather than, I'm going to predict where volatility is going to go 2 weeks from now or something like that. And over the course of those 7 years, the number of reasonable sized players, the big players in the marketplace, had dwindled a lot. It was, maybe there were 10 internationally, 7 or 8 there were real players in the US, maybe less than that. So as soon as you're talking about that type of number, now all of a sudden, some of the brands that your audience would be familiar with are the people that dominate. So think of the Citadels of the world, the Susquehannas of the world, the Virtus of the world, right? These are predecessors to some of the other companies you might know today. Those are deep-pocketed organizations, and as is fairly well known to most Wall Street Journal writers, they also have pretty deep relationships with brokers. So deep relationships with Ameritrade and Schwab and E-Trade, or what today you would think of as people would say Robinhood. The Citadel Robinhood relationship is quite famous at this point over the last year. So as one of those real players left in the marketplace, we had we're competing with huge companies that also had this natural advantage in these relationships they have with the brokers of the world.
Right.
So,
and also with their scale, they can fund the arms race.
yeah.
And they can get lower and lower latencies.
So to answer your question about Deephaven, is the latency race in real-time markets at the time was single microseconds. Today, it is a nanoseconds race. Okay, it's certainly there. And the reason we started Deephaven was not because we wanted to drive that need for speed. A general purpose data system can never achieve, or today cannot achieve speeds like that, and certainly could not back in 2011, 2012. The reason we started Deephaven is because we felt like we should take our math and computer science team, our talented team, and allow them to make money in strategies, or encourage them to make money in strategies beyond option market making. So other asset classes, other holding periods, other more traditional quantitative strategies that we thought we were well suited for, and also could be scaled, right? You could say you can put more money to work on those types of things. So in pursuing that was really a business shift. Oh, let's diversify, so to speak. And in pursuing that business shift, we wanted a general purpose data system that was really good for quantitative finance generally. And that's why we built Deephaven.
Cool. Let's dive into that transition a little bit more. So you were running Walleye Capital for some number of years. Was it like 10 years or so?
At this point, I think it's 7 years probably when we first started building this application.
Okay. And then so you spun out this technology that y'all had developed internally that was based on some problems that you were facing and trying to diversify your strategies, right? And then now you have a standalone technology company called Deephaven, which you're the CEO of, but also Walleye still exists and is still using this technology internally. So yeah, I guess let's just talk about how you transitioned and spun this technology out and what happened.
I misrepresented the calendar a little bit. So for the first 7 or 8 years, we were just market making. We started building this technology in 2011 or 2012, largely because we just, we had some pretty simple criteria we wanted for a data system. We wanted it to be really good with real time and historical data. Real time meaning milliseconds, not sub-milliseconds. We want it to be generally useful for quants, but also to be a real data development tool for applications of all sorts. And we wanted it to be generally valuable for everyone at the firm. Now, everyone at the firm was, everybody at the firm had a STEM degree or was certainly leaned heavily towards math, but there were a third of the firm, 2/3 of the firm would not consider themselves accomplished computer scientists. They might be an actuarial scientist and be incredible with Excel and, could write macros, but, we're certainly not a C++ programmer, so to speak. So we had those 3 criteria. Hey, real time and historical, generally useful for quant and other stuff, and accessible for everyone. And we wanted it. So we wanted a system that could check those boxes, and nothing did. So we rolled our own. And it was used exclusively inside of Walleye for about 4 or 5 years. It evolved a lot, as you can imagine. We invested pretty heavily in it. And we saw some things happen at Walleye that we thought were indicative that this was a pretty interesting piece of technology. People very much turned into armies of one and could self-service a lot of their use cases. Our quants felt like they were moving quickly. We could observe that, wow, we felt like we were developing strategies quite efficiently, and people were happy and no one was leaving the firm. And one of the things they cited was, man, I really love using this system. So the partners and some of the founding engineers like Chip and I, had a discussion at the time and said, hey, what do you think of rolling this out to the world? The world seems interested in software like this. And very, very importantly, even selfishly from Walleye's perspective, great technology is very expensive to develop, and oftentimes it's smart to mutualize the cost of those developments. So instead of one company just, we're going to keep making it better, hey, let's get a lot of people around this thing and see how good it can be. So it was spun out in essentially the beginning of 2017. And I think we had a humbling experience, appropriately so, for a few years where, we had to find product market fit. We had to make it more Python first. We had to evolve our user experiences. We had to handle some use cases that were very important to other enterprise buyers that weren't fundamental to us, or weren't fundamental to Walleye. So Yeah, so we spent several years servicing a good number of quite sophisticated Wall Street firms. And then in 2020, late 2020, we felt like we had really good product market fit. And in 2021, we knew that it was time to take the next step in our journey, which was to take many of the important components and open source them or provide community versions of components of the system so that we can engage developers and users like those that might be listening to us now in a much more modern and innovative way.
Cool.
Yeah, and to give you a little bit more insight into the early environment that kind of, forced us to think about this technology. At that point, it was taking us typically a week to a month to answer, an important quantitative question. What it may be a new signal generation, or it may be understanding how we're getting picked off on trades, or what have you. And we really needed that time to get down to like a day. And so we needed something that radically changed how we worked. And that was a major driving factor for us.
So yeah, so that's a good jumping off point to talk about Deephaven specifically. So we'll transition to the part where this is spun out and you've open sourced it. So yeah, I guess first let's just give the high level overview of what Deephaven even is. Like if you go to the website, it looks like it's kind of this big toolbox of like data visualization, streaming tables. It's a query engine. It can hook up to real-time data. It can do all sorts of stuff, right? And so, yeah, I guess in the context of answering these questions you had as a quantitative hedge fund, how does Deephaven help you here, and how does it streamline your operation?
Sure. So I think there's two ways I want to answer that question. The first is just paying homage to its history and the way some customers use it today. It is a data system that can be used as a data system for many, many use cases within a complex team. I want to do quantitative stuff. I want to build data-driven applications. I want to support headless communications between nodes in real time. I want to use Python and Java, and I want to support visualizations. Wow, it actually can do all of those things. Why? Well, because we built it for ourselves and we had a couple hundred people that wanted a lot of different stuff. But I do think that it might make sense to focus on its differentiators and its core reason to exist. So I think we look at Deephaven as having two fundamental differentiators. One is we truly believe it is it is a first-class system and maybe best of breed system in regards to real-time data. Again, remember where we came from here. We hold real-time data quite dear, and it is an evolution beyond stream processing, right? So most real-time data is really focused on, hey, I want to do stuff with an event stream, and we think event streams are fantastic. They're very, very valuable. But we have introduced another construct, another object called a streaming table that is a very nice complement to batch tables and a nice complement to event streams, and it will be very intuitive for your users in that it's a table, but it can change underneath. You just operate on the table just like you would with pandas or something like that. But underneath, there's new rows added, there's stuff modified, things are moving. It can, and everything will just work in real time.
So think of it like a real-time data frame.
For sure. Yeah. So let's quickly talk about how it compares to other solutions. So things I talk about are your typical like pandas data frames, right? And I've also talked about a number of like databases. So like Timescale is a time series database, and a lot of different solutions for either for querying data locally. So yeah, can you kind of compare it to what's out there, and that'll give people a clear picture? Because you have like the visualization component, but also you have this data frame component, and talk about how that data is stored and queried.
Sure. Chip, I've been dominating. Do you want to?
No, go ahead, Pete.
Okay. So we think of, I mean, Deephaven is really a suite of projects is the way to think of things, right? I think the one that is most fundamental and most central, we call Deephaven Core, which is a data engine, a query engine. Okay, I can think of it as so fundamentally it's a worker, okay, that can connect to static data, sources of static data. So think of a Parquet file or something like that is an easy example to understand, and or receive streaming data or from real-time sources. So a perfect example is, oh, I hook it up to Parquet and I ingest some Kafka feeds, okay, or and you know, you may ingest from a number of sources, but I think that's a fairly popular one today. Okay.
Yeah, a simple example we have on the blog is just pulling crypto data from I think Coinbase over a WebSocket.
Mm-hmm. And then invariably this is a query engine for working with both those static sets and streaming sets at the same time. You know, one or the other if you like, but arguably both at the same time using the same syntax. So Deephaven has invested heavily in a couple of things. One is the support of table operations. Table operations meaning things you could do. You know, pandas are table operations, right? Or SQL or table operations generally. And delivering very optimized, well, you know, good performance for both those real-time and historical table operations, and also strong architecture to support delivering Python or Java actually, but Python primarily for your audience, to those table methods. So when you write an application in Deephaven, really you're just going to bring up a Python experience. It will be Python in every way. You could use it for non-Deephaven stuff, but then there's ways to interact with the Deephaven table API via Python, and even to embed Python user-defined functions or third-party libraries, or have slick integrations with PyTorch or something like that, where, again, is a model akin to perhaps what you do in Pandas. But again, the difference here is, oh, all of this can change in real time. All of this can support streaming first class, and you can be more or less naive to what's going on but underneath or under the covers.
So yeah, I guess, yeah, I think that's what I need. I want a little clarity on like how the actual like real-time data analysis works. Like you can look at the historical data that you ingest, and let's say Chip, you mentioned this Coinbase WebSocket feed. So what are some examples of like what you can do with it and how these operations work in real time?
Yeah, let me kind of give a little more clarification. So inside Deephaven, there's this abstraction of a table, and a table you can think of as being like a real-time data frame or a static data frame, but it all looks the same to the person using it. And so you could hook that up to CSV or Parquet to get static data. You could hook it up to Kafka or a WebSocket or, you know, a custom data ingestion to get a real-time table. And then once you have a table, you can do table things. You can filter the data. You can do joins. That includes time series joins, where if you have two time series where the timestamps don't align, you can do joins and say, you know, give me the value that happened just before this. And at that point, you can do all of your quantity type math. You can do aggregations. You can evaluate formulas. And so really we've abstracted out the data source, and you can plug your data source in, and then you just have tables to work with.
Okay. And then, so on top of that, so let's say I've done some analysis and I've determined something, or I want to trade something, for instance. Let's say I'm using it in this fund. I saw that you had this interactive brokers plugin, right? And so I'm assuming the way this works is that you can run these real-time calculations on the data that's streaming in, and then is the idea, yeah, how does this interactive brokers plugin work? And you just respond to these real-time, I guess, data points that are being calculated?
Okay, so I guess there are a few things to think about. So, in the Interactive Brokers plugin, Interactive Brokers provides data sources. These could be, prices or even fundamentals or what have you. It's just data available through Interactive Brokers. And so the plugin makes those different data sources available to your program. You can also take data sources from elsewhere. If you want to download something, from Quandl or wherever else, you could bring that in and use that as part of your calculation. And then you do your calculations, and let's say you end up with a table that is the trades you want to send to the market. So at that point, you can just have that. Yeah, there's two ways you can execute those trades. One is you can just, when a change happens in that table, you can call a Python method, which says, okay, go do this trade. The other thing you could do is when you have a table, you can have a listener to the table and say, okay, this changed. Now I need to do these things. So there are kind of two ways you can approach that.
Great. And then, and as I understand it, there's also a whole visualization component as well. So you also have like what do you call it, like a notebook interface, or it works with Jupyter notebooks as well. But also I saw your page has a whole lot of different data visualizations, and I assume those work real time as well. So I don't have to like build, like a lot of complaints I've got, I build these JavaScript real-time charts and such a lot, which takes a lot of time. But as I've seen it here, it looks like you might have the ability to generate these automatically.
So, one of our goals here was, productivity of quants and people doing quantitative work. And to make somebody productive, first of all, they need to be able to get in and touch and feel the data and answer questions quickly. The other thing they need to do is be able to see the data. And so, we've brought all of those things together.
Awesome. So let's talk about, I noticed you have two different versions of this. There's an open source, like community version, and an enterprise version. So, Deephaven, it is a business, right? But you have an open source component to it. And so I've talked with a few different like library and framework authors. So Quant Connect, and also some authors of FracTrade and various crypto frameworks and things like that. And they all have different models. Some have like a SaaS model. Most of them have some type of open source component. So can you talk about like the benefits of like, why would you open source some of this technology and make it available to people for free? And what benefits, that clearly provides some benefits for you. Why work with the open source community?
Sure. This has been an interesting journey for us over the last 4 or 5 years since we've been involved in this. I think it's potentially relevant to ground oneself in really where we came from. We were involved in a business that was a productive business and a successful business. It's still operating today. It's a customer. We like the people there. They're doing great. And we genuinely brought this out, yes, because we thought it would be good for walleye to neutralize the cost, but also development, and we could innovate more quickly. But really, we just thought, man, we think this thing's pretty good and we want people to use it. That really was an important part of why we brought it out. So that was true on our enterprise only journey, or our Wall Street focused journey, for a few years, working through a few customers. But, over the last number of years, the data software, not all software, but the data software industry has really moved in the direction of open source, or open first, or open dash, you name it. People have different religions on these terms, so I want to be careful with them. I think the only exception, or the biggest exception to that, is probably Snowflake, right? Snowflake is using SQL, which is well understood and more or less delivered kind of something that people understood, and they delivered it in a cloudy way, and that was their innovation. But if you look at the other big players in this space, Databricks, even Confluent with Kafka coming out, is open, is streaming, is open source. So it certainly got our attention about, what's the appropriate business model here? Also, frankly, if you talk to enterprise buyers, there's not individuals that are involved in. There's not an individual that buys data software. It's always a team, and the team is always comprised by lots of opinions and lots of influencers, and developers and data scientists are very heavily featured in that group. And they, like you, they are identical to the people on this call, like us. And we're all grounded now in, hey, what's out there in open source? Is it supported? What are the people like behind it? what's the quality of code? Can I extend it, et cetera? So it became quite obvious to us that this is actually just the way data software is going to work. And so from our point of view, it is very consistent with the culture and priorities that we held dearly. But also from a practical point of view, open mattered. Open was we wanted open formats. We hated the idea of vendor lock-in. Like, we want open formats. We don't want interoperability. We were a huge fan and huge user of Envoy, a huge fan and user of Arrow. Like, if you're going to be involved in this stuff, you have to embrace the spirit of it as well. So it made sense to move in that direction. What I think we found, and I think we're on a journey that will take us who knows where, really. But what we found is we had a very big system that can do a lot, as you suggested, right? You've asked questions like, wow, it seems like it has this and this, and the answer is yes. There's data lifecycle tools. There's all sorts of access control systems built into the Deephaven system. And you can imagine, wow, it sounds like an aircraft carrier. Are you really going to bring an aircraft carrier out to open source? And really what we found was, no, what we want to do is we want to deliver value that people can interact with quite immediately and understand, and we can tell stories about. So the approach we've taken is that we are open sourcing or making available to the community free, extendable, forkable versions of components, right? So when my kids were trying to understand, Dad, I don't understand how this is going to work. I don't understand the economics of it. The analogy I told them is, for our religion, people have different religions about this, but for us, we're bringing out the engine, the suspension system, the tires, the radio, the audio system, and we want to work with the community to make each one of those things great. And if you want an engine, man, we really hope you use ours. We really hope you partner with us. We really hope you let us support you for free in good faith, because if we do that, we know that engine is going to be kick-ass. And the same thing with the tires. Somebody else, they just want tires. Like, we hope you use our tires. We think our tires are great. And by you using them and complaining about stuff 5 years from now, those tires are going to be better. And what we know, or what we think, is there are going to be some enterprise buyers out there that they don't want an engine. They don't want tires. They just want a car. And so we'll have a lot of different constituents that we're able to serve in a number of ways.
Cool. So yeah, so in the community, you mentioned you want to learn from different stories and you want people to adopt this and see what they can do with it, and you'll learn from that. So can you talk about a few people that have used it? Maybe there's some surprising use cases. Like, are you finding that individuals at home, hobbyists, people working on different types of businesses are adopting this and using this for purposes that surprise you? Or are there organizations or other, like you mentioned, starting it with Walleye, are there other funds that are using this same technology? I assume that would be on the enterprise side, but I assume this also goes outside of finance, right? This is just a general data streaming solution. Like, I noticed you gave some, I just had my fancy football draft or whatever. I saw that you had given some sports, like analytics types of examples on the site as well. So can you talk about some ways people are using Deephaven in finance, but also other contexts?
Yeah, absolutely. So, and I appreciate you saying that, because I think one of the challenges we have, but one of the things we're desperate to do, is make clear that this is not a capital markets product. This is not a finance product. This is, it's, people ask me, what can you do with it? I'm like, I don't know, like, code to data. What do you want to do? Like, kind of that. I mean it. Yeah, if it's sub-millisecond, maybe you shouldn't use any general purpose data system, let alone ours. But other than that, code to data, what's your use case? Go. And so that means, massively outside of capital markets, massively outside of fintech is where we think it belongs. We think the future of data infrastructure is real time. We think that's going to matter across all industries. But today, obviously, things like IoT and industrial telemetry matter a lot. Crypto and blockchain are foremost, are clear consumers of this type of stuff. real-time gaming. So for example, we have conversations with a couple big game producers that have that are trying to use this to explore interactive experiences for gaming communities beyond just like leaderboards and things like this. We have it's obviously relevant for things like developers or quants that are working in clickstream or retail or recommendation algorithms. We talked to a big food and beverage retailer that has some people on his team trying to use it both for recommendation algorithms on stuff that are parsing voice from drive-throughs and marrying that to real-time inventory management in store. Wow. And you can imagine all that needs to be done in the context of historical and batch data as well. So we think that there's a good range of use cases that can be delivered to the platform. We're careful not to overstep our expertise in regards to industry. We think we know quite a bit about the capital markets, but I don't want to walk into United Health Group down the street and try and tell them how to do healthcare data. Because even though I genuinely believe the future of healthcare has a component of it that is real time, both in managing our health through, Apple Watch 2035, whatever it looks like, right? But also trying to manage the economics of service, with millions and millions of people and hundreds of millions of transactions going through healthcare systems in a day, trying to optimize that and learn from it iteratively and in real time. So I think there's many exciting opportunities here. For the most part, the ones that are catching our attention now from our support channels and conversations there's a couple of crypto firms themselves that are using it quite heavily to build production grade infrastructure. And these are, so that's very exciting. And then we have a lot of individuals that are using it for IoT, like personal IoT hobbies. Oh, I live out west, and I have my buddies and I all have devices set up for smoke detection, and I want to create little alerting mechanisms and UIs that we watch to see what's going on. I keep track of, my bike has feedback metrics in regards to my performance on my bike, and I want to, use those I want to use that data, to be able to do analytics and even see cool things on my watch as alerts pipe through that infrastructure. And Deephaven's a good tool for that type of stuff.
Awesome. And I was going to jump into, I was going to focus on a few, specific features. I think you've already covered a lot of them. I'm getting a few questions from folks in the chat. So I guess there's naturally a lot of people ask about comparisons to other products. So Spark was mentioned, and also Snowflake. So yeah, can you kind of compare those a little bit? I'm not as familiar. I follow Snowflake, the stock, but I actually don't know the technology very well. So can you talk about the differences between your solution and these other?
I'll take the Spark, and then you can grab the Snowflake. Sure. But so to do real time with Spark, the normal way to do that is Spark streaming, and there are positives and negatives to that. So what Spark streaming does is it takes your data streams and it breaks them up into batches, and then you can use the Spark compute engine on those batches. And so it's good in the sense that you have all of the power that's available in Spark, but it's bad in the sense that that's basically you have a project which is Spark, and very late in the development cycle you add a major new requirement, which is real time. And so whenever you do that, you end up with a final system that's not what you had designed if you started from scratch. And so you end up with some compromises there.
Excellent. And
yeah,
then,
I think Snowflake is similar. I mean, people at Spark or Databricks and Snowflake would probably suggest they're in a battle that's head to head now. Maybe they came from slightly different places, but they're very much there. So Snowflake is, from my point of view, is distributed SQL in the cloud, right? So SQL databases typically, you know, it used to be kind of all one flavor. You wanted to have, it was really for operational loads. You wanted to manage your transactions, right? That's the way the world thought about databases decades ago. And then, you know, and now it's, and then it moved quite readily into, oh, I want to build analytics. I want to use applications on top of those workloads. So Snowflake's reason to exist was, oh, people should be able to do analysis on, you know, on a database with faster turnaround than they do today, which means they should be able to get stuff there more quickly, launch more quickly, right? And once you have a database set up, get better feedback loops. Things should be faster. So they said, let's try and get all the DevOps, all the IT crap out of the way, and let's create a SQL engine that, you know, behind the scenes is able to take advantage of fast compute. And that means not only a good engine on a single thread, but something that could take advantage of many processors at the same time. So, and they did that fantastically, right? So sort of famously, oh, I want to create a new Snowflake database. You could very quickly. They had good support. Things, you know, they're servicing largely, you know, people, DBA types and people that have hung around DBA types, and the user experiences were very elegant. And then you'd run a query and it seemed fast, like, you know, because they had a nice engine and they had an engine that could reasonably take advantage of the niceties of the cloud. It was a cloud only solution, right? So in a year and a half ago, they really started to take seriously real-time data, streaming data. And now if you go to a Databricks conference, real-time streaming is a top 3 priority. You go to a Snowflake conference, it is a new top 3 priority. And what else did Snowflake do? 9 months ago, they bought Streamlit. Oh, we don't want SQL now. We also want Python guys, right? Streamlit's like a builder for Python dashboards and things of this nature. So I think it is interesting to watch well-capitalized firms move in directions that we care about and we hold dear. But as Chip suggests, one, for some of these things, it's going to be difficult to bolt it on in a way that's interesting. And two, we think our experience, the capital markets experience, sort of driving its whole enterprise off of real-time data for a couple of decades, is a head start that's pretty interesting. And in both cases, and very specifically, how are we different, like technically than Spark? How are we different technically than Snowflake? Okay. So first, it will feel like a Python application. Okay. It will feel like, oh, I can do Pythonic stuff. The syntax of the table operations will feel Pythonic. I can use user-defined functions. Chip and his team has worked pretty heavily on a learn library that's gather, compute, scatter paradigm for integrating our real-time structures with, you know, Python libraries generally, but, you know, PyTorch and TensorFlow and scikit-learn in particular. So, you know, these are specific things we've done to cater to people like we think might be listening to us and engaging with us right now. But then also, this is really important, and it's kind of wonky technical, but it is the reason that Deephaven will be difficult for other people to emulate. So when we think of like, let's say you have a billion record table, and 10,000 rows just changed. Oh, it's like a billion rows and 100 columns. And you have 10,000 rows where a few of the columns changed, and then another 5,000 new rows just came in at the bottom. So everything about Deephaven, from the API to the engine itself, to the user experience you might be touching or feeling, is only caring about a small amount of data. It's caring only about deltas. It is moving around deltas, and it is doing calculations on deltas. So again, think of it was a billion row table, 100 columns, and I just changed a small amount. 5,000 new rows came in, 10,000 rows had a few columns changed. So, you know, I had those 5,000 rows times 100, right? And then you have a few columns times another 5 or 10,000 or whatever I said. a very small amount of data change. So I didn't have to move much. I didn't have to do many calculations, right? For every other solution, Snowflake, Spark, etc., they had that billion row table. It's now different. They need to move it. They need to do calculations on all of it, right? So when we think of how to become cheaper, more efficient, how do we address workloads that are more dynamic, we think this architecture is fundamental because it puts the statement data is dynamic, data is changes as a first principle of the system. And the architecture in the background is always, the engine's different. It's not doing, like, we don't do calculations on data, we do calculations on deltas of data. So it's just a very different thing that opens up a lot of capabilities that are closed to others.
And you said that same approach goes all the way to the UI as well, right? So if I had like a billion data points, I noticed you have like a data grid component and stuff like that. So it can like selectively, it loads what it needs to show at any particular time.
Yeah, so yes. So we have a blog post about our grid. We're really quite proud of our grid. I think the blog post is titled how to see a quadrillion rows in the web. Okay. So here's everything about Deephaven architecturally is lazy, which sounds terrible, but is really important. So you want to move as little data around as possible. Okay. So your question of, does this also extend to the UI? Let's think about real-time data the way the world thinks about it. Real-time data only exists in one way in the natural world, right? Something happened. Now something else happened. Now something else happened. My heartbeat, right? I don't know. A package arrived from Amazon. Now a package arrived from UBS. Those things are events. There was a log in a computer. Now another log in a computer. Those are events, right? An event stream is the only way that real-time data occurs in the world. So that's how we all think about it. And that's why it feels so fundamental. But what Deephaven does is, with this streaming table, we support not just appending data, but also random reads to that table at any time as it is changing. So our UI is really structured as viewports. So at any given time, your client is saying, I don't care about the table. I care about this thing, this part of the table. That part might be static. It might be changing or whatever, but it allows us to support tables and widgets, which are really just visualizations on top of tables, in a very, very dynamic way. And so when you say, like, oh, I have a world of 100 Kafka feeds, and I have lots of different ways I want to combine them and visualize them. For users of Deephaven, if they have spent 5 or 6 hours thinking and working, they will be able to self-support any use case like that. They don't need a UI developer. They don't need to be a high-level Python programmer. They don't need C++. They don't have to write JavaScript and create their own front ends. It's just they need to do some table operations, and then the viewports magically happen on the web.
Can you talk about how are those two things connected? So I have this backend table that's ingesting all this data, but I have this UI on the web. I assume it looked like there was like a React grid. So how do those two things is there like an API for that like, am I actually making a web request to some little server that Deephaven is running that returns what I want?
You for the most part have it right. You'll launch a Deephaven server, or arguably a number of Deephaven servers. One of the things that we think is very important is being able to connect these Deephaven workers, these servers, to each other so that they can get each other's work product in real time. Okay, so you can have this data mesh, this graph of real-time data flowing from server to server and back. But if you take one Deephaven server, any Deephaven server can also be connected to from clients. Those clients, we have like an open API that then on top of that has client libraries in a variety of languages. One of them is JavaScript. So we use that JavaScript API to then deliver. We've built a React front end that has some interesting components and some things that will work out of the box and we think you might find valuable. We've also created a plugin system so that it should be quite easy for you to, introduce new widgets or attributes to that user interface without having to do too much. But yeah, it is that React front end that is then communicating with the Deephaven backend over an API that we've built. And by the way, that API is itself an extension of Arrow. So Arrow is probably something your community is familiar with, right? So if as a super fan of Wes is with pandas, obviously I follow him through Arrow. Arrow is now quite an accomplishment as well, right? And what we've done is, but Arrow is batch data, so it's fantastic, zero copy sharing between applications for tables, but it's batch data, it's static, and that's, as you can tell, inconsistent with our priorities in the world. So we've extended Arrow Flight, which is the communication over the wire, to support dynamic data. And now we move those table deltas that I talked about as payloads in Arrow Flight, between the server and the client, in this case, a JavaScript application.
Awesome. So yeah, so let's say, cool. So this sounds awesome. So if I want to get started, so I'm convinced that I want to build something on this, the best way to get going. So you mentioned languages, so I can write either a Python app or a Java app, it sounds like, and even there's a JavaScript connection for front end as well. Are those the main, like the core languages? But you're kind of focusing more on Python due to just the data community.
Yeah, so
interest.
Go ahead, Chip.
So there are two concepts here. One is code that's running on the server. And so that is typically like Python quant code, or it could be Java code. And then you have the option of creating a client that connects to that server. And that would be like our JavaScript web interface. We also have C++ library, Go, Python, and I'm not sure which other clients we have. So, those are your typical options. And if you're first trying it, I think just go to the Deephaven website, and you can click a button and it will spin up some hardware for you, and you can try it right there without any work.
And then, so I guess speaking of spinning up hardware, so will most people, it's a very powerful system, but just a regular like a cheap laptop, is that enough to run all of these different components? Is that fine, or do you recommend something?
So you can certainly run it on a cheap laptop. Really, it's a question of, what exactly are you trying to do? This is designed to work from small data up to, a user that's importing tens of terabytes of real-time data per day. And so those guys are not running on a laptop.
Right.
Really. But, it will run on a laptop without a problem. I think the minimum memory requirements, maybe 8 gigs of RAM, something like that. But I know we've had people run on half a gig.
Okay. And then I guess for those folks that are running terabytes of data, right, ultimately, do they end up running on a server, like an AWS type solution? And you mentioned being able to spin up one in the browser, and I saw that on your website. So is that also a service you provide where you like host it for them, or you're not in that business at all? Like I know Timescale has like a Timescale cloud, for instance, and they allow you to pay per hour for an instance or something like that. So how does that work when you have to scale up to a larger system?
Yep. So what we've, again, the way we're approaching open source today is trying to make things easy and valuable, and trying to partner with people, not partner, but support you as you move into more sophisticated use case, and we're trying to think about where the world wants to get to. So we've tried to make it straightforward to connect different Deephaven workers, or to scale them, as would suit you. So we're mostly agnostic about what sort of hardware you're using, and whether it's physical or virtual, or any of the case, or whatever the case might be. From a product perspective, we don't yet today provide Deephaven as a cloud service. Frankly, we would love your engagement, your community's engagement around advising us about that, because we are split, and this is a priority for us going into 2023. And I think we're split on whether it makes sense to launch this as an independent service, or to try and couple it to services that the community might already be using in the cloud. Like, oh, I'm already using such and such a data service. I'd love it if Deephaven could match really nicely with, I'm using this OLTP service in the cloud. I'd really like it if Deephaven could just spin up automatically and work well with that. But I think it is, probably Vegas odds would suggest we'll just launch an independent Deephaven as a cloud service, which is pretty turnkey in AWS, Google, and Azure, as you would expect.
Awesome. Okay. And so I could get started with my own server and my own laptop, or maybe in the future there might be some service for this. And so, yeah, what's the best way to get started? I know you probably have a collection of like example type projects from different domains. Is there a GitHub that we should be familiar with? And like, yeah, what else can you
I haven't prepared too much, but I could probably try and riff here on the fly if you want to.
You want to show us? Can you show?
I could share a screen and we could.
Yeah, I'll throw this up there.
See what's here. I thought we'd do more talking and FaceTime, but why not try and show?
Definitely show some stuff. It's hard to visualize what all of this stuff looks like.
Yeah, I mean, and it's a Saturday. Who knows what's coming out of my mouth today, right? So,
sounds good.
Okay, so can you see my screen?
Good. It's black right now for me.
It is.
Yes.
I'm gonna stop my video.
Okay.
I'm gonna move. 1 second. I'm gonna just try and move some things around. Maybe you'll just have to entertain your audience for a second.
Yeah, sure. What's up, everybody? You can. You might want to stop your share and reshare it or something. I'm not sure.
Okay, so
what the deal is, I see it on the left side, but I don't see it. Why do I not see it?
Do you?
Oh, wait a minute.
Come on, baby.
Lost Pete.
Oh, we did.
No, I see you. You hid yourself. Yeah, I don't see your. Let me. I'm gonna kick your. Kick it out.
All right. Can you guys see?
Yeah, I can't see your desktop for some reason. We tested it earlier though.
Okay, you guys can still hear me though, yes?
Yeah, we can hear you. I don't know if maybe Chip could share something and then you could talk about it.
Try that.
Oh,
yeah. You can probably turn your camera back on. I don't think that matters. So maybe Chip can just share the screen and you can.
All right. Can you see my screen?
Something? Or even I could even share as well. So if you want to.
Yeah. Can you see here?
I don't see yours either.
Oh wait. Whoa. Hold on. I got all kinds of stuff. Hold on. I think I can share. There's too many. There we go. Okay. I see. That's Chips right there.
Okay.
Yeah.
Right.
So that's right.
Yeah. So, on the website here, you've got try demo. This will spin up some hardware for you. And then if you look, down here, there's a tutorial that can walk you through doing some things. Over here on the right, you can look for particular topics. So if you're interested in data science, just go into that folder. If you like scikit-learn, just click on it. That'll appear down here, and you can go through and run different parts of it and give it a try. Otherwise, if on the website, if you go to docs, there's a quick start to get started. And there are various how-tos and tutorials on any concepts you may be interested in. And I think that's a good way to get moving.
Awesome.
Hey, Chip, I'm gonna send you. Why don't you go to a command? I'm not able to watch you because I'm gonna be on a different screen.
Yeah, my computer's a mess right now.
Can you go to the command line though?
Somewhere. Let's not do that just because I don't know where my command line is.
Okay, that wasn't
Okay.
fun. Come on, Matt.
I'm
I'm gonna try and share one more time, see if I get lucky.
All right. There we go. I got it.
I don't know why. Okay, cool.
For some reason, you're appearing like 4 times. I see your screen now, though.
Okay, so let's see if I can get lucky here. So,
Oh, look at that.
So you just see the command line, right? So
Yeah.
I'm gonna pip install a Deephaven example app. Okay.
I always like when the CEO is still deep in the
And then I'm
command line. He's not just a storyteller.
gonna run. So now I'm
He's
running.
also a client.
That's a good line.
Yeah, I forgot the little commercial.
Okay. So now, so I just ran an example app, and now should be able to go here, and I just need to find my Chrome. And the reason I just copy that URL, and now you're seeing the Deephaven front end, okay? And the reason I ran this example app, so all this example app did is, let's see if it's out here actually. If I go to, I think I can go to GitHub Deephaven examples. I don't know if Chip showed you this because I was and there's all sorts of downloadable, or applications that have different use cases here you can use. And the reason I ran this example app, which is one of those, is that it's not just the Deephaven doesn't come up empty. Essentially, it comes up with an integration with Coinbase via WebSockets. So
can you zoom in a little bit?
All you're doing is we're connecting to Coinbase getting WebSocket updates here into this table. So if you look at matches table, whatever, these are crypto trades going on in the marketplace. Usually we show, oftentimes I would show financial market data, but on a Saturday, that's not too helpful, right? So you can see just fundamentally what happens here. This is just connecting to a raw feed. And you can see that one of the dangers of showing you a UI is you think that this is just a UI. Really, this is the materialization of a UI, of viewports into data that's going on in the back end, right? And if I say the fundamental way to think about this is every Deephaven table, or everything in Deephaven is the table. So if I wanted to see a second table, I could take the first one and then I could do something to it. So now I'm interacting with our API, and I could say, I don't know, I'm just going to show you something very simple, right? Where now I have two tables, right? The original one, and it's derivative, right? So the original one was matches table. I did something to it. In this case, I just filtered, and now I have a second table, right? And the way this works is it sets up an acyclic graph, a dependency, a logical tree, if you like, so that the original continues to update, matches table, but also so does this derivative, right? And the sophistication of what you put here, sky's the limit. Just if I hop to another environment, right? I'm just going to I'm going to use a static table for, that's not going to work. Sorry. I tried to take a dynamic table.
And it's just right here at the bottom left here. Is that the code that's behind this, that's powering this, or no?
Oh, I just,
yeah, so the code in the bottom left is the code Pete's trying to get to run right now.
Okay.
Yes. Oh, what just happened here? Oh, I got it. This is why you don't run demos when you're what? There's no data from yesterday. What's the
What you do the 31st?
So, this stuff is, so these, obviously you can handle real-time data.
Zoom in a little bit.
You can handle real-time data like that I was showing you before. You can handle big data. This is 19 million records here, right? And again, all you're ever doing is you're writing, you're writing instructions one after the other, just very linearly, right? So you're not battling an optimizer or something else. You just write one instruction set, name a table, use that table, write the next instruction set, and you can do, all the things that you would expect with tables. Oh, here I'm going to run a bunch of different aggregations, and then I'm going to, color the format and things like this. And all of it can be done with static data, which I'm doing here. This is the financial markets, so it's not open today, or it can be done with dynamic data, as you're seeing with crypto over here, right? And
that's cool. And you can actually style all the it's not like you're just saying the plain text data. You can actually visually present your table. Like I noticed they're like highlighted green and yellow.
You can present it, and I feel terrible. I should have prepared it. I apologize to your viewers. It would be like, and these widgets can all, this UI we think is pretty sweet for interrogating data and building applications and exploring things. But these widgets can all be made available in Jupyter as well. So these table widgets, plotting widgets, etc., can be standalone in Jupyter. So, and again, even though they're in Jupyter, where you're sort of used to running a cell, seeing the output, running the next cell, in the case of Deephaven, you can run a cell, and that table can be like one of these tables where it's a ticking table that has updated, that has state, that is updating, as new things happen in the world. So it's a fairly powerful construct. And oh, by the way, this goes well beyond, just simple table operations, because, this is Python. So one of the things I'll often demonstrate when I'm on a real pitch call is something like this, that, it goes out to Seeking Alpha, right? And it grabs the transcript of Seeking Alpha, and then it uses libraries your audience will know well to clean up the natural language processing, and then do machine learning on those transcripts to determine the sentiment analysis, to determine the sentiment of the call, right? And all of this is just using, Python, as you would expect, in combination with, our table libraries. So.
And can you open, so you had that Coinbase example with the streaming data. Can you open the code for that? I don't know if GitHub is the best place, or does it just appear in here?
I'm trying to think.
I just kind of wanted to get an idea of like how much or little code, is required to do something like that.
Chip, will you just entertain for a second? I'm going to find it.
Yeah, actually, if we go to the blog, let me see if I can. We have a simple example in the blog, if I can find it.
I'm going to find this exact thing. Okay, here we go.
And then maybe zoom that in a lot. And yeah, maybe we could walk through just one example while we're on here.
Okay, so this, Chip, you could probably talk this through better than I can, I would think.
Yeah, so I've never read this code, so let's do it. So, right here, there's a dynamic table writer, and this is a useful thing if you're creating your own real-time data source. And so what this does is it provides an interface that will give you a table, and it will give you then a method you can call to populate the table as you get more data.
Right, and what it's doing, I assume so here's the Coinbase, right? It's connecting to this, right? And it's using, the Python WebSocket library, right, to connect to that. Yep. It's using this JSON, and then it's structuring that JSON as tables and using that method called dynamic table writer, right? So I'm just going to Deephaven docs. I'm going to community docs. I'm typing in. That didn't go. Sorry. Yep, there we go. Dynamic table writer. Oh, come on, Pete.
There you go. Oh, nice.
Right, and now, here's a description of that with reference material and things like that. Right.
So all you really needed to do, it's just the So you took the normal Coinbase WebSocket interface, and then you can just call one method to append to this dynamic data writer, and from that, it'll show you an entire like real-time updating data grid widget that you can also query from the browser.
That's right.
It's that simple.
Yeah.
Awesome.
And then you
okay.
can see, like, here's a perfect example of, let me just make sure I hit the right thing. Right. So I have, instead of me doing T2 on the fly, I have matches table here. I'm going to put something called matches stats here, which is doing an aggregation of different things. And sure enough,
And so as that real-time data is coming in, like the raw real-time data, you have a real-time aggregation that's happening and being reflected in another table.
Yep. So the original table created created this table, and then you take that table, matches table, and now you're doing this matches stats on top of that matches table, right? Which is just doing these simple aggregations.
Awesome. And then, so this is happening in real time. So what happens? What if I want to like persist, like, does data just go away? Can I somehow preserve this or store it somewhere? Is there a record of all this real-time data that came in, or is this just
so
transitory in memory, or what's the deal?
That's a great question. So this is something that we are bringing to community. So and again, this is something that we would love to have community engagement directing us, because we have a few alternatives and a few priorities to balance. So in enterprise, in our enterprise product, we certainly have this. So in Kafka world, you can think of Kafka feeds having a Kafka broker, right? A central agent that does two things in my head. One, it persists real-time the Kafka streams, and then the second is it federates those streams to downstream workers in our, that are doing stream processing. In our enterprise product, we have the exact same thing for streaming tables. So we're writing down streaming table records, and we are moving it from this centralized agent to other downstream workers. In bringing this to community, we want to bring persistence to community, but we need to make decisions about how best to do that, so that it's interoperable. Should it be in, for example, an Arrow payload that is Kafka compatible, for example? That might be very interesting. Should it be something that we don't make compromises on, and we develop all our own, because streaming tables are slightly different from other forms of table communication. But that's a project that we have lined up for the next few months. Right now, what people will do is they will either write to Kafka, which certainly we support in a first-class way, or arguably you can snapshot and write to Parquet, or you could snapshot changes and write those to Parquet.
Yeah, and if you want a Kafka example, I think we have one in the blog and also in the documentation. So those are things we have. But, if any users, want to try this and there's something they're not sure how to do, we have a community Slack channel, and that's a great place for people to jump on and start asking questions. Or, like we have the interactive brokers integration. If there's a demand for Alpaca or some other integration, that's a great place to request it.
Awesome. Well, this is great. You've already made, seems like you're making work for me. I'm already getting some people saying they want to see a Deephaven project tutorial for me to create. So that'll be fun. I'm looking forward to checking it out more. Cool.
Well, this was, that's great to hear. Again, we're very enthusiastic about being involved with the community. I sort of see it bimodally in that, we think we're quite experienced with the capital markets, and we think it'd be very exciting to talk to people that are interested in trading in the capital markets and finance and stuff like that, because we may be able to support them not only in the software but also in their use cases. But we also we enter other conversations on different footing, where we're invigorated to support them with the software use, and we're just all ears about its applicability in their work environment, the use cases in front of them, or the hobbies they're trying to explore. One thing, if you'll indulge me for just a moment, I have, oh man, I really hope this works right now. Can you see my screen again?
Yeah. So it's the Steve Jobs. And one more thing.
So
I have one right here.
So this is a dashboard that
nice.
that I built. This is a hobby interest of mine. I like baseball, and there is a baseball game. I don't know. Do you like baseball, Larry?
Oh, well, I'm more of a football guy from Texas. So
so the Major League Baseball supports a fantasy game called Beat the Streak. Unlike Beat the Streak, or unlike other fantasy games, you can play this one for free, and if you win, they give you 5.6 million real dollars. It ain't fake.
Jeez.
So so it's a really interesting game. But we also think it's a great opportunity to bring a bigger community around baseball if they could make it real time and interactive. So we've created dashboard experiences around the league, to try. This is all in simulation because we don't have the data available to us for Major League Baseball. But I think it shows sort of the range of use cases that are relevant here.
Absolutely. I've been noticing a lot of different sports data type of channels emerging recently. And, there's all this interest in the betting markets as well. So I've considered creating a side channel or exploring this some myself. I noticed so there's another guy that does the whole sports data Twitter, I think, and he's created videos about learn Python via baseball, football, basketball, and it's just like another fun way.
Yeah, there is. We have a couple blog pieces around real-time sports data and fantasy.
I collected cards growing up, so I definitely have the interest in the stats there.
Yeah.
Unfortunately, they didn't become as valuable as I expected them to. I'm supposed to be retired by my Ken Griffey Jr. card, whatever. But it never quite made it, unfortunately. But it was a very fun bonding experience with the family. So cool. Yeah, I love your I wish there was more. I don't know. I feel like sports, they should publish more of that sports data. I haven't really explored all those APIs as well, but I feel like that would have tremendous interest. Like I noticed people take ESPN and Yahoo fantasy data and they'll build their own. There are people that scrape it or build their own private, on top of their private APIs and do cool projects.
So I'm jaded, Larry, and I've been, I don't drink the Kool-Aid, I swim in it. So I very much see a world not that far away, not 20 years, but 10 or 7, where there's a lot more data centralized and publicly available and a lot more real-time data. So one of the things that is, like, even think of this phenomenon, right? So, hey, you want data from something, you go to their website, you figure out where the heck the link is, and then you download a CSV. Like, what a mess that is. Like, really think about that. What a mess. Like, why isn't there like a central catalog for all public data available in the world? And oh, by the way, why shouldn't a lot of it just tick in real time? And so Deephaven infrastructure today can support that. Like, that's not speculative. We can support all of that. So we really look forward to, hey, let's all work together, because I'd love to get some of these monster companies, understanding our view that, look, this isn't that hard. Data can be decentralized but made available in a lot of ways. And oh, by the way, all of it can be quite real time. And that's going to empower a lot of innovation and a lot of opportunity for people that maybe don't have opportunity in the same way.
I think I was talking to Chip a little bit earlier before you got on, and I was talking about like how this channel started. And it started like I tried to write a Python script to trade a Robinhood account, and they didn't have an API. And there's various people that reverse engineer that stuff and figure out how to send the right requests and the right payload to do that sort of thing. And there was some Robin track account that tracked what like Robinhood traders were following, and then people faded them and all that. But there was like some cool project. But then I've seen just in the past few years that some of this data is becoming more and more open. Like if we mentioned you starting in 2005, there wasn't that many of these fintech type companies that were sharing all this data. And I think that's what's brought yeah, Chip was asking me about the crypto markets and interest there. And yeah, there was like a huge wave that happened in the past couple of years just due to the fact that this data was so readily accessible, the real-time data, because I was like surprised when I first tried, because I started with stocks, but when I first tried crypto data, the fact that I could just hook up to a WebSocket and not really ask, I didn't really have to beg someone's permission and ask them, you know, send them my birth certificate and all that to see data. I just like WebSocket, send message, and like, wow, this whole stream of data is here. And then my most popular video, all these people are like, wow, I can build this thing, just, you know, this little bot or whatever, and subscribe to that data. And that, you know, and then it attracts people around the globe too. So the channel audience is like 80% international, you know, outside the US now. And so I started just talking about S&P 500 and stuff like that. And, you know, to a lot of people, that's not as interesting as, you know, this real-time data that's available. For all
well, we, you know, we think that as the technology becomes easier to use for real-time data, all of a sudden you just have that much more imagination, that many more people saying, oh, I can now deliver this as well, right? So, and then all of a sudden the people that don't want to share data as readily because it's how they're monetizing part of their business are going to, you know, they may have their hands forced, or they'll be encouraged, or they'll be enlightened, and there'll be more data available. And I think that'll be an interesting time. In the interim, I encourage all of you that are at least Interactive Brokers customers to work with Chip and see if he can help you discover interesting things about the world using Deephaven. And if you have accounts in other, you know, we're happy to either write or support you in writing other integrations with those APIs. If you think Deephaven is interesting, you know, we just need your engagement to point us in the right direction.
Well, absolutely. Perfect. So yeah, I think that's a good ending point there. I just want to say I appreciate you and Chip spending some time on the weekend, especially on Labor Day weekend, to talk about some nerdy data stuff with me. And thanks to everyone who showed up in the live chat. And I'll definitely be talking to folks and exploring it more and trying out some different things using Deephaven. So I appreciate your expertise, and also just people that, you know, have your decades of experience with this stuff, being willing to engage with all different types of communities and, you know, democratize data, and also share these tools that required, you know, Chip probably worked on all this for years and years and years. And then, so just sharing that with the open source community is amazing.
Oh, well, we're, you know, it was genuinely our pleasure. You're giving us the opportunity, frankly. You've got a real knack for connecting with people, clearly, and they're following you for a reason. So just being able to be a part of that for an hour is a real treat for us.
Yeah, thanks for having us.
Hey, yeah, thanks for showing up, and yeah, thanks for sharing all this information. I'm inspired to create something with this, so thank you very much.
Cool. Thanks.
Right. Cool. Thanks a lot. Have a great rest of your weekend. See everyone next time. Thanks. Bye-bye.